So now we are starting with lesson 6, and our notes begin on page 23. So on page 23, you'll read this. Hannah has some blue paint. She wants to lighten the shade, so she mixes in 1 cup of white paint. The color is still too dark, so Hannah keeps mixing in 1 cup of white paint each time. After adding 4 cups, she decides the color is too light now. Okay? Explain in words how much paint Hannah should have added initially to get the shade she wanted. So we know she needed added at least 1 cup, and she needed to stop at 4 cups. So she needed to add more than 1 cup, but less than 4 cups. Okay, and if you saw on the last page, what we're talking about in this unit is compound inequalities. So compound, if you think about compound, it's a mixture of things. And so we're going to take and mix some inequalities together. So on this one, we're going to actually symbolize what those mean. Represent your answer to part A with 1 or more inequalities. So we want X to be more than 1, or at least 1 cup, and we want X to be less than 4 cups. Okay? So, greater than 1 and less than 4. Okay? So, what we want to realize, the other thing that we will learn, this is a compound inequality because we're mixing 2 inequalities together with the word and. So we want both of these to be true. So that's our word and when we want both of them to be true. We could have written this another way. We want it to be that we want X to be between 1 and 4. So we want X to be less than 4 and we want 1 to be less than X. So this is what a compound inequality also looks like if it's an and situation. Okay, and we're going to learn about or in just a second. Hannah decides she likes the shades of blue that appear between adding 1 and 4 cups of paint. How can you represent the number of cups of white paint that yield the colors that Hannah prefers? So we just did that right up here. This is what it's asking for. We wanted to make 1 inequality instead of writing it as 2 different ones. And so that's what it would look like. How can you use inequalities to describe this set of numbers? So we're now on page 23, and you're going to write this in your left-hand column. So what we want to do is we want to realize that there are 2 inequalities here. One of the inequalities is X is less than or equal to -3, okay, because it's a closed-in circle. The other inequality is X is, because it's an open circle, it would be greater than 2. So what this shows us is it's either going to be this one or it's going to be this one. So we actually put that in there. And with the or situation, what I call an or situation, is that it's saying that this is true or this is true. But or, think of or as friendly. It's going to include everything and as part of the solution, or is going to include everything as part of the solution. So keep that in mind. So this is how I would write that inequality. This next one I believe is in your book, and we want to write this. So we have 2 ways we can do it. My favorite way is just to write it as 1 inequality. So I'm just going to take this and pull this information all down right here. Well, it's saying that it's the stuff in between -2 and 6. So X is between -2 and 6. This is an open circle, so that's going to be no line, and it always points to the left as long as it goes from smallest to large, small to large. Your inequality signs are always going to point to the left, okay? So keep that in mind. This one's a closed-in circle, so it's going to be less than or equal to. Okay, that's one way you can write it. That's my favorite because it's so easy. You just pull all the information right down. The other way you can do it is that you can say, look at each part of it. So if you could see me right now, I'm covering up the 6, and I'm saying one of my parts is just this, open circle going that way. Okay, so this is, well, what's that inequality? Start with the x on the left-hand side, it's much easier, and then it's an open circle, and it points the same way as the graph. But it's also this one, so it's and now it's also 6 going this direction. So it's x is less than or equal to 6. So you can write it like this, or you can write it like this. They are both the answer. Solve the compound inequality negative 3x plus 2 minus 7, or 2 times the quantity 2x minus 2 is greater than or equal to 6. And we're going to solve this. This one is in your book, so I'm going to solve this first equation, this one right here. I'm going to solve negative 3x plus 2. I'm going to leave that there. I'm going to rewrite the 2 times the quantity x minus 2 is greater than or equal to 6 right over here. And all we have to do is solve each inequality. So we did this in lesson 5. So we're just going to solve each inequality. So we're going to subtract 2 from both sides. Negative 3x is greater than negative 9. Divide by negative 3. And we get x is greater than negative 3. But then we have this little word or. It's important. I'm going to put it there so I don't forget. Now we're going to solve this inequality. Go! So when you solve the second inequality, hopefully you came up with x is greater than or equal to 4. Now we're going to graph this. So I have a negative 3. Now you don't have this number line, so just draw a number line. Okay? And this one told me exactly what numbers I need on it. But you're going to draw a number line. I need to make sure you have negative 3 on it, and I need to make sure that you have 5 on it. Let's put a 0 too. Okay, so your number might only have those. We don't have to have all the numbers. Okay, I made a mistake on the first one. Did you see my mistake? Do you see my mistake right here? Okay, what's my mistake? I divided by a negative. When you divide by a negative 3 or negative anything, that's going to flip your inequality sign. So this should be going the opposite direction, and that makes a huge difference in our answer. Okay, so now I have a number line on mine, and you do not. So all you're doing is drawing a line. Okay, you don't have to have all these numbers. You need to have the negative 3, and you need to have the 5, and let's put a 0 in there. And now we're going to graph. Okay, so x is less than negative 3. Less than means it's going to be an open circle, and it's going to go to the left. Okay, because all the numbers that are smaller than negative 3 are over here. Or x is greater than or equal to 5. So we have a closed circle, and it's going off in this direction. And when we have an or, that is our solution. Both parts of the inequality have to be on there. Now this one is not in your book, so I'd like you to write down this problem in the left-hand column on page 24. So I'd like you to write this down. Negative 12 is less than or equal to 7x plus 9, which is less than 16. Okay, so if you don't have it written down, pause and get it written down. What is happening here is that we are looking at a compound inequality, and I'm going to mark some stuff out because I can't cover it up with my hand. So I'm going to do is I want you to understand is that if I just have this part, let's pretend I just have this inequality. What would you start off by doing? You'd subtract the 9, you'd keep going, then you divide by 7, right? So the only difference with this one is that instead of having sides, you have three different regions. So where you see the inequality signs, we're going to draw lines. I'm going to draw them dotted. And that makes it so that I have 3 different areas. But whatever I do to one area, I have to do to both of the other areas. So I'm going to, in each one of these, I'm going to do the same thing every single time. So if I look at just that beginning equation, I'm going to first start by subtracting 9 from every single section. So I get negative 12. 21, I think. I'm going to have to look that up. So yes, my calculator told me that it is 21. 7x, bring down those inequality signs. Bring down the inequality sign. 16 minus 9, and that would be 7. Okay? Now, again, we have to solve for this 7x. So right here, I have a 7x. How are 7 and x connected? Right, multiplication. So I'm going to divide by 7. I have to do it to every single section. Okay? So we get -3 is less than or equal to x, which is less than 1. So if I have a compound inequality, and this is an and. This is an and what we need to understand is if I have and, it's what do they have in common? What do they have the same? That's where I'm going to be shading. Or can be any place, and it's going to, in or, we're going to include all the stuff. Okay, so now we're going to graph this one, and these are really nice to graph. We have a -3, we have a +1, so 0 would be about right here. Then just bring everything down. Okay, look at that. What is my, on -3, what is it going to be? Right, it's going to be a closed circle. And on 1, what is it going to be? That's right, it's going to be an open circle. And look where x is. That means it's the stuff in between here. So this is my graph. It's the stuff in between, which is right where x is. Okay, good. Okay, so now I'm going to circle the word and so that I remember that when I get to the end. That's going to make a huge difference in what my answer will be. So I'm just going to rewrite these down here. I'm going to, if you don't mind, I'm going to go ahead and distribute this one at the same time. So I get -2x minus 2 is less than 4. And I'm just going to bring 4x plus 1 is less than or equal to -3. And it really doesn't matter the order because you're going to be graphing both of them. Okay, so let's solve each of these. Let's pause and solve each of these inequalities. Go. Okay, so with these two, we solve the inequality. X is less than or equal to -1. That one was no big deal. We divided by a positive. Whereas on the second one, we divided by a negative. And when you divide by a negative, of course, your inequality sign has to go the opposite direction. And so that's the reason it turns out this way. And now what we're going to do is we're going to graph both of these on the same number line. So I have a -1, I have a -3, and I usually put 0 on there also. Heck, -2 is in between, so I'll just put that in. Okay, so let's graph each of these. I have x is less than or equal to -1. X is less than or equal to, so colored in circle. Okay, and then I have x is greater than -3, so open circle going this direction. Okay, now this is where and comes into play. And means where do they have the stuff in common? So where do they have in common? So do I have this in common? Is this what I have in common? Nope, that's just for one of the graphs. Do I have this in common? Nope, that's just where one of the graphs is. What do they have in common? Right through here. So that is my graph, is just this stuff right here. Okay, and we would actually probably take off these because they are not part of it. Okay, so graph it in there to begin with, but then when you're all done, and what I should have done is just regraphed it down here and said, here's -3, here's -1, open, close, and the stuff in between. Okay, good. Okay, so now we're going to solve word problems involving compound inequalities. I added this info needed because this problem doesn't make sense unless you have this. There was another word problem that I could have done. I figure you can get it on too. It's not super difficult. So, first off, you need to read the info needed. Enrique, who was the owner of the dog River, plans a diet for his dog River in which the dog only consumes between 510 and 500 calories per day. There are 320 calories in one serving of dog food. River also gets treats, and that's where this part comes in. That's in your book. Suppose River has new treats. Okay, we didn't know about the old treats, so it doesn't really matter. And his treats are 10 calories each. How many of the treats, because again, you didn't know about the old ones, can River have and remain in her calorie range? Okay, so that's the word problem. We've read the whole thing. Let's pick it apart. So first off, it says between. So we know that it's going to end up between 510 and 540. Now, can it be equal to it? Yes, it can. And if I'm talking about between, this is going to be an and. So I want both of these things to be true, if I want both of them to be true. So that means that I'm going to have it that it's going to be between these. So it's going to be like this. And if you write a compound inequality, it always goes from smallest to largest, okay? And the arrows will always point to the left. Now, what goes in between? We're going to have to symbolize it. 320 calories with 1 serving of dog food. Oh, wait, before I go any further, could it also be equal to? Yeah, because it's between those, so it could also be that, because we want to consume either 510, between 510 and 540, but they can be included, so it has to be an equal to. So the calories are, wait, what does X stand for? How many treats? How many treats? So X is the number of treats. Okay, so that's going to give us a big clue. That's going to be our variable. So we have that River is going to eat 320 because 1 serving per day. Okay, 320 calories and 1 serving of dog food per day. I didn't type all of that on. And then it is 10 calories for each treat. So 320 plus 10 calories for each treat. This is our inequality. So we're going to solve this one. So notice what's happening here. Remember, this is where we want to draw our different areas. Until we get used to these, I would strongly encourage that, so you remember that you have to do work in every single one of the areas. Okay? So we start off, we want to, and again, if I were with you, I'd be covering up part of the problem. So I'm going to actually do that. So pretend like this part isn't here. And if we have this inequality, what would you start with? Well, you'd start by subtracting 320 from all the different areas, right? From both sides. Well, the only difference now is that now you have 3 areas. So we have to subtract from all of them. Okay? And we keep working. And we get numbers. 10x is in the middle. I've got that one. And we subtract here. Is at 220. And here, 190. I'm going to pause and check my work. So yay, the calculator said that I did everything right. So let's keep solving. So again, look in this middle part. I have to get rid of the 10, so I'm going to divide by 10. Whatever I do to the middle, I have to do to the outside sections as well. So I end up with x is in the middle, and it is less than or equal to 19, which is less than or equal to 22. Okay, so how many of the treats can she now have in order to stay in the calories? So River can have between 19 and 22 treats and still remain in the calorie range. Good. So now we're going to go to page 25. Do you know how? So I want to check and make sure that you understand how to do this stuff for the homework. Okay, so this one is write a compound inequality. Well, first off, notice there's 2 parts to it. So if there's 2 parts, we know it's going to be an OR. And then we just have to write each of the parts. So remember, put the variable on the left-hand side. It tends to be easier. Okay, and then my inequality goes the same way as my sign. It's a colored in circle, so it's going to have a line underneath it to color it in. The other thing is you can always check mathematically. X has to be everything smaller than -4. Okay, so you write that other one, go. So hopefully on this one you realize that X is going to get bigger. It's going to be greater than, because it's colored in, it's going to have a line because it's also equal to -1. And that's your answer. For number 6, you have 2 different ways that you can write this inequality. One of them is that you can just bring everything straight down. Just bring it all down. So I have a number line. Whoops, not a number line. I'm writing an inequality. So I have 2, and I have 8. 2 is a closed circle. And as long as it always goes from small to large, from left to right, then your inequality signs are always going to point to the left. And here I have an open circle, and X is the stuff in between. Good. So now we're going to solve and graph this one. We have an and. Okay, so let's see what happens here. We're going to solve this by solving, so just go through right now and do each one of these. Pause your video and solve those. Go. So check your work, make sure that you got the same thing that I did. If not, look over my work. So on the first one, I added 1 to both sides and I divided by 4, so x is greater than 1. On the second one, I distributed, so -6x and +8 because I'm taking a negative times a negative. and that makes a positive. I then subtract 8 from both sides, getting negative 24. Then I divide by negative 6. Divide by a negative? That's right. I have to flip my inequality sign to go the opposite direction. Okay, so let's make a number line and graph. And we have the numbers of 1 and 4. Okay, and we know that the first one is going to be an open circle on 1 because it's just greater than. It goes off to the right. And then on x is less than or equal to 4, it's a closed-in circle. Closed-in circle. It's going to the left, but it's an and. So where is and? It's got to be the stuff in between. So if I'm going to actually solve this one, first off, this would be my solution. Okay, and my graph, then what I have here, my final graph, would be between 1 and 4, open circle on 1, closed circle on the 4, and it's the stuff in between. Okay, now I could write my final answer then also as 1 is less than x, which is less than or equal to 4. Great. So on this one, always look to see whatever the compound inequality is, make a note to yourself. That's going to be an or. So that means everything's going to be included. Okay, so I'd like you to pause your video again and solve each of these inequalities. Go. Okay, so we solved each of these inequalities. We distributed and got 8x plus 6, subtracted 6, divided by 8. X is greater than or equal to negative 2. Here we added a 15, divided by negative 5. Yes, we divided by a negative, so look, that inequality sign switched direction. Woo, and it even moves around. Okay, so let's graph each of these. We're going to make our number line. We're going to put on a negative 2. Oh, wait. Negative 2 is our biggest one. Negative 2, and we have a negative 4. Okay, and 0 would be over here. So let's graph each of these. We have x is greater than or equal to negative 2. So this is a closed circle on negative 2, going off to the right. And we have x is open circle, going off to the left. And that is what happens. Now, if I can for just a second, kind of go off to the side here. What if I would have a graph that is an or, and what happens is that, let's say this is a 3 and this is a 5, and it ends up that I have an open circle going this direction and I have a open circle going this direction. Well, it's an or, so or is everything included. So that means my solution here would be everything. That would be in all real numbers, because everything makes it true, because it's not only in this section and this section, it's in all of the sections, it's all the number line. Okay, so let's take another scenario. Let's say that we have the scenario and it's an and. This one's going to be an and situation. And we end up with, here's 3 and here's 5, and we have open circle going this direction, open circle going this direction. Well, and has to be what they have in common. Do they have anything in common? Nope. So this would be a no solutions. Now there's one other type I want to bring up, and that is if I would have an or, and let's use 3 and 5 again. Here's 3, here's 5. Okay. So we have 3 different scenarios I'm talking about here. And if I would have it's greater than 3 and it's greater than 5. My final solution, remember, or includes everything. So if it's or, it's going to be from here on over. And if it's and, it's going to be from, oops, let me find a color we haven't done yet. Nope. It'd be from here on over. So or goes here, and goes here. So this is where and would be. And if we have an or, it would start and go all the way over here. That's more of an Algebra 2 concept, but I just kind of like to point that out to you. Great. Okay. Word problem, you know we're going to have these. Nadine plans to ride her bike between 12 and 15 miles. Okay, I told you that we would see this again. Notice that what we're using, distance is equal to rate times time. Yep, you're going to have that formula memorized. Write and solve an inequality to model how many hours Nadine will be riding. So it says between, so you're going to go between 12 and 15. Between, can it include 12 and 15? Yes. So it's less than or equal to. Now we're going to be using this. Okay, and it wants to know how many hours. How many hours did she go? So we're going to be using that information along with this information right up here in the pedometer, or is not pedometer, but in the rate. So that's our rate. So we're going to go that t is our variable, t is time in hours, because that's what they want to know. And we're going to take the rate times the time, okay, because we go a distance. So now we're going to solve this. Go. So hopefully you made your lines and knew that you had to do it for all three of the areas. You divide it by 10, and so you got 1.2 is less than or equal to t, which is less than or equal to 1.5. So how many hours? Between 1.2 and 1.5 hours is how long she will be writing. Now this one is not in your book, so I'd like you to, on the bottom of page 25, there's hopefully some room down there still. If not, find some space. Probably there's a little space over in the left-hand column. Copy this drawing. So I want you to copy this triangle right here and the information. Okay. And then we're going to show our work. Okay, so the value for the area of A, so there's our area, that's where area of each figure is given. Write and solve a compound inequality for the value of x. So it's a triangle. How do I find area of a triangle? My formula is 1/2 base times height. Okay, this one you should probably have memorized. The other one you should probably have memorized is base times height, and that is for a rectangle. Okay, so now we're going to plug that in. We're going to take and plug in this area. So 9 is less than or equal to the area, which is 1/2, times the base, which is 3, times the height, which is x. Oops. So I could have just done 3x is less than or equal to 12. Okay, so I get 9 is less than or equal to 3/2 x, which is less than or equal to 12. You have an option on how you want to solve this one. We could multiply and get rid of the we could multiply every single term and clear the fractions by multiplying by 2, or I could multiply every single term by 3. I'm going to go with clearing my fractions. So I'm going to clear my fractions. So I get 18 is less than or equal to, my 2's cancel. Then I'm going to divide each term by 3, because remember, I didn't do it, but I should have. I should have made my little parts, so I remember that. So I get 6 is less than or equal to x, which is less than or equal to 8. So write and solve a compound inequality for the value of x in each figure, and there it is. Good. So this next part of the video would actually be on the second day. So if you know you're going to be back tomorrow, you can just stop right here and go work on the homework. But if you're not sure, feel free to go along with us. Okay, so essential questions. This is in your book on page, I believe it's 25. What are compounds, inequalities, and how are their solutions represented? So a compound inequality means that it's more than one inequality. Okay, how are their solutions represented? Well, we have an or and we have an and. And we're going to have more than one inequality and what they're going to be looking like. Look for relationships. If A is less than B, how is the graph of x is greater than A and x is less than B similar to the graph x is greater than A? How is it different? So first off, let's look at a number line so that we can at least get our bearings as to what we're talking about here. So it says A is less than B. So that means A is on this side and B is on this side. So I always start off, if I'm like, oh my gosh, that's a lot of words, draw a picture. Always draw a picture. So now it's saying, how are these graphs different? So if I did this one, that's an and, so it'd be the stuff in between. If x is greater than A, that would be this way. X is less than B, it'd be this way. So this graph right here would be the stuff in between. Okay, then it wants to know how does that compare to x is greater than A. So draw that inequality. And for that one, it would just be A, and it would be an open circle on A going off to the right. Okay, so what they have the same is they both go to the right of A, everything bigger than A. But on this one right here, it has to stops at B. Whereas this one continues, so it's all the values greater than A. And that is what they have the same. They both have this. This is true over here too, but this one stops at B. So what they have the same is its values greater than A, but the first inequality stops at B. Number 3, I'd like you to read this one and give me your ideas. And if we were in class, I'd be asking right now, what are your thoughts? Why do you think that we would use the word compound when compound is defined as a mixture? I hope you paused yours and wrote something down. I'm saying that it would be compound because it's a mixture. It's more than one inequality. And our last one, error analysis, and this is important. Kona graphed the compound inequality, okay, and it's an OR. So let's graph that compound inequality right here. So we have 2, and we have 3, and 2 is open circle going this direction, and 3 is open circle going to the right also. So they're both going here. And what he did is that he said, oh, okay, well then that means my final graph would be from 3 on up. Okay? Well, if it were an and, this would be right. This is an and. But because it is an or, it's going to look like this. It's going to go from 2 on up. So this is, if I take this inequality right here, this compound inequality, if it is an or, it looks like this. If it is an and, it looks like the second one. Okay, because there is a difference. Great. Okay, so that is all for the videos, and hopefully that makes sense. And in class, it might be slightly different, but you now have all the information for Lesson 5. Thank you very much. If you have questions, you know where to find us.